Hello. I just bought one of these 46 range true RMS digital multimeters at Radioshack. Now, what does that mean exactly? Well, I know that RMS stands for root mean square. Let me see if I say this correctly. When you have a sinusoidal voltage and current output, so the voltage comes up to Vmax, the actual power produced by that sine wave is proportional to the square of the maximum voltage. Let's see, power equals V squared, so it would be like something like this, the power output. So if I took the mean of that voltage squared, and then took the square root of that mean, that actually turns out to be 0.707 times the maximum voltage, if I remember correctly. Let's check. It's 1 divided by the square root of 2. And yes, that turns out to be 0.707. I think if you're really good at calculus, you can actually calculate this as, like, if this wave is sine squared of x, and you take from 0 to 2 pi, and take the integral of that with respect to dx from 0 to 2 pi, that would give you the area under that curve. And then you would want to take that area divided by 2 pi, because that's this length here, to get the average height of the curve. Plugging that into Mathematica, integrating sine squared from 0 to 2 pi and dividing by 2 pi gave me a height of 1/2. So this average height is 1/2 here, and the average height, the average height squared is going to equal 0.707. Is going to be, no, I'm sorry, the square root. Boop. The square root of that average height. The root of the mean squared. So here's the square, here's the mean, and here's the root. So RMS, root mean squared. The square root of h is going to be 0.707. If we plugged a Vmax in there, squaring it would make it Vmax squared. We'd still have Vmax squared here, 1/2 Vmax squared, and then when we take the square root, we'd get just plain Vmax. So what does it mean for it to be a true RMS digital multimeter? I realize that I don't exactly know. The nice thing about the true RMS of a sine wave voltage is that it gives you something proportional to the average power going through the circuit. But not all waves are going to be sine waves. Looking up true RMS on Wikipedia, though, I see an example of a possible voltage that is not a sine wave. Looked up true RMS converter. According to this, most low-cost multimeters convert the voltage into a DC signal, convert the signal into a direct current signal of equivalent value, and they multiply by a correction factor, which only works if the input signal is sinusoidal, so probably 0.707 times whatever the maximum current is. I guess the problem is that in the cheaper multimeters is that the internal circuitry is capturing some maximum current flow rather than the true average power. Alright, so what does it mean by 46 range? My guess is that if you counted all of these, including maybe the K-type thermocouple, the logic test function, maybe even the low battery indicator. it would have 46 different ranges of values that it could measure. Some of these I'm familiar with. If you put the dial here, it's measuring voltage. Then you can hit the select button to decide whether it is measuring DC voltage or AC voltage. If you want to measure voltage, you should put your black probe here and your red probe here. The resistor between these two nodes is essentially like an open circuit. Unless you're putting the device into a situation that it isn't designed for, there shouldn't be any current going between those two wires. On the other hand, if you connect that to a voltage exceeding 600 volts, you may break the thing if you haven't already killed yourself. Oh yes, it might also blow the fuse inside the device. That would prevent it from breaking completely, frying the components inside, but you'd have to replace the fuse. Now, if you want to use either of these two settings, you're going to need to put the red probe over here in this area. Now, when you're measuring the current, instead of acting like an open circuit with a huge resistance, as it was over here, the probe is going to be acting like a closed circuit with a teeny tiny resistance. Alright, I just plugged the red wire into the 10 amp max jack. Here's what happens when I turn the knob to measure volts. Hopefully you can hear that. Alright, so the device has been programmed with a warning to tell you that you're probably about to do something foolish. Alright, so the thing is, if I have a circuit here with a power source and a load, load just meaning anything that I'm trying to power, there is going to be one of two things that I want to ask my digital multimeter. One is, what's the voltage going across this load? And the other is, what's the current going through this load? If I want to find the voltage going across it, I don't have to change up the circuit. Just have to connect the red probe over here and the black probe over here, and then those will go through the meter. Let's call it the Digital Multimeter, DMM, and then I'll just connect that probe over there also to the digital multimeter. I just clip the probes to each end of the load or the power source. If I did that, though, with the red probe attached here, we'd have a major problem. Well, depending on how big this voltage is over here, we could have a major problem. It's the same thing as if you take a battery and just lay a piece of metal across the ends. What happens is that the battery is going to send a lot of current through there, and it's going to heat up the battery. If that's just a 9-volt battery, it's not a huge big deal. It'll heat up the battery, probably destroy it in a matter of minutes, but it's not going to be going to kill anybody. If you hook that across like a circuit in the house, that's going to, in the best case scenario, it's going to blow a fuse. In the worst case of scenario, it's going to set your house on fire. Alright, so you only want to use that jack when you're connected to the amps or microamps. Any other time you want to use the volts. It looks like, though, this thing can actually measure milliamps as well. So if you want to have a really big resistor in the circuit and measure milliamps, then you would use that jack. The next thing I just did, I tried out this setting. I selected select until it either measured in ohms or farads, so apparently this thing can measure in capacitance as well. And so I held on to both ends, and I read up here that I held on to both ends, and it gave me that I had a electrical resistance of approximately 1.5 mega ohms. And then I tried something else. I went and stuck my hands in a pan of dishwater, and I came back out and it said that my electrical resistance was around 0.8 mega ohms. So getting your hands wet reduces your electrical resistance. Now, everything beyond this point, in fact, even the capacitance, I don't think I am familiar with most of the multimeters that I've seen did not have the ability to measure capacitance directly. This thing has a logic test function, which I think is this thing here. Okay, here's some trivia. If you hit the range button, it will change from like the millivolt setting to the volt setting to the 60 volt setting to the 600 volt setting, etc. But if you press and hold it down, it will go back to auto range. You gotta hold it down for 2 seconds for that to work. It says, do not connect the test leads to a voltage source while the function switch is set to anything other than voltage. Doing so could damage the meter. So you don't want to be measuring the electric field, I guess. You don't want to be measuring the frequency, and you don't want to be measuring any of this stuff. If 0.f appears in the voltmeter, that means that it is an overflow. Indicates the measured value exceeds the range rating. This is normal when you measure resistance or a diode, or when you keep the test leads disconnected. If you are measuring a voltage or current when overflow displays, disconnect the test leads from the circuit immediately. So overflow on resistance or diode is fine. Overflow on amps or volts is bad. Disconnect it immediately. Now this relative delta button seems to be for zero offset measurements and relative measurements. It says in the manual that zero offset applies to the voltage, the current, the resistance and capacitance, and the frequency functions. The meter shows zero offset for some ranges, especially well, it says here, for the 4 nanofarad range of the capacitance function. It says press rel delta to remove zero offset. It says for the capacitance function, you need to remove the test leads from all circuits. But for all other functions, you need to touch the leads together. So that will, I guess, zero it. Capacitance is proportional to the surface area of the plates divided by the distance. I guess if the distance is big and the area is about 0, that makes capacitance 0. So if you want to take a relative measurement from 0, you would unhook those 2 leads. On the other hand, the resistance obviously goes to 0 when you're touching the things together. So if you're using zero offset, it says to, I guess if you're doing those things and you don't have a 0 up here, that means that you have some kind of zero offset. You need to hit the rel delta, and then it says the meter is in manual mode, and take the measurements with the rel delta displayed. But if you want relative measurement, it is also available for voltage, microamps, milliamps, ohms, farads, and hertz functions. You can take a measurement relative to a reference value. So it says 1, locate the element you want to use as the reference value. Component or circuit, I don't know where I got element. Then select your function, say, I don't know, ohms, and measure the reference value. Then when the reading appears, hit the rel delta. While rel delta is displayed, measure the other component or circuit. I guess hitting rel delta will set we'll set the view up here to 0, and then the meter will, when you measure from there, measure another component, and the meter will display the value relative to the reference value. Then, to exit the relative measurement, press that button again. If the reading is bouncing around wildly and you want to be able to read it better, you can press the hold button and it will hold the display until you hit another button or set the function switch to another position. The meter will turn off after 30 minutes if left unattended. If you want it to be if you want it to be locked on, turn it off and then press hold and select and turn on the meter. And then, that is an exceptionally hard thing to do, but once you do it, let's see, where is it? I guess it's maybe over here. P, L, O, C will appear on the screen until you let go of these buttons for power lock. There are a lot of notes regarding measuring capacitance in the text. Measuring capacitance on the low scale, it says, might be close to the internal capacitance of the digital multimeter. So it says, to measure such capacitors, use the relative measurement function. Says electrolytic capacitors vary with the voltage, and this meter does not use high voltage to set the electrolyte, so it cannot measure the absolute capacitance value for a high voltage capacitor. It says if you're checking diodes, then set the switch over here and then hit the select button and a little diode will appear up here. Always power off the circuit under test and discharge all capacitors. Then connect the test leads to either side of the diode and observe the first reading. Then reverse the leads, so connect the red and black on the opposite side and check the second reading. If one reading shows a value of overflow, then the device is good, as the meter shows a value reading, and then the other side shows a value reading. When it shows the value reading, the plus side of the test probe is where the red lead is connected. I guess this is the plus side and this is the minus side. So my interpretation of that is if I put the plus side over here and a minus side over here, it'll say overflow, but if I put the plus side over here and the minus side over here, it will give me a number. The number will be some voltage, like 0.2 volts or 0.5 volts, all the way up to a maximum of 2 volts. If it is more than 2 volts for the positive bias of the diode, then this device will not measure the capabilities of the diode. You can measure frequencies from 10 hertz to, looks like 4 megahertz here. It says actually 10 megahertz in the book. And with duty cycle, with signal frequencies from 10 hertz to 10 kilohertz. What is a duty cycle? The cycle of operations of a machine or other device that operates intermittently rather than continuously. So if I put this thing over here and then hit the select button, I can toggle between hertz and duty cycle. And if you connect it to duty cycle, it will have a percent sign over here. Alright, finally, measuring the electric field. it says remove the test leads from the meter. So take them out completely. Point the top of the meter and the built-in antenna. I guess I cut off the picture here, but I guess there's a built-in antenna somewhere in there. It says point the top of the meter to the object under test. For best sensitivity, hold the meter behind the function switch. So I guess that means you want to put your hand so that it wraps around here. If the meter detects an electric field, 1 to 5 bars display corresponding to the strength of the field, and the buzzer sounds. So I think that is a pretty good coverage of what this digital multimeter can do, and I will bid you farewell.